Welcome back to our ongoing discussion on the CR30 Programmable Safety Relay. I believe this is part 6, and we are finally getting to the wiring diagram. So we're going to go through as many examples as time will allow us, and we're going to start out really simple with just an EStop button and nothing else. No test pulses, nothing. Just an EStop button, a 2-wire safety EStop circuit. And we'll continue from there. So let's get after this. Adding a circuit, electrical design. We're going to start, as I said, with a dual channel EStop without test pulses. And you can see all that we have is 24 volts DC. We've applied it from 0 to 24 between A1 and A2 on the CR30. And then we are applying 24 volts DC to both contacts, both normally closed contacts on an EStop switch, and we're running from there to safety inputs 0 and 1. So let's look at our circuit. Let's begin with the operator station that we're going to use in all of our labs with this product. And it's basically a push button station. We have an EStop with 2 normally closed. We have a momentary push button. These also have lights in them, LEDs, blue, red, green, and most of them have one normally open, one normally closed. Then we have a potentiometer, and we have a 3-position selector switch. Primarily we're going to use just the EStop, and we might incorporate one of these buttons as a reset at some point. And the nice thing about these push button stations with a clear top is that you can see the wire colors on the switches from the top. And if you flip it open, you can see that we have unique wire colors on everything, but we can see plainly, like for the EStop, that we have 2 red and 2 blue. So we come down here to 2 red and 2 blue, and those are the 2 sets of contacts that we're going to use for our EStop. Looking real close at what we have connected to our CR30. The main 2 connections are right here on 24 volts DC plus and common 0 volts. So we're bringing in 24 volts DC through the red and the black conductors here, and you notice that we have 2 red terminals jumper together and 2 black terminals jumper together. That gives us a quantity greater than 1 for connecting up 24 and 0. We are coming in through a fuse too. That's not necessary, but I used a lot of this equipment in training classes. It's not a bad idea to have a fuse. And remember, the fuse doesn't protect this device. The fuse protects the wiring going back to the power supply. So you've got 24 volts DC wired into the CR30 here. We're also bringing 24 volts DC over to a terminal strip that's just out of your view. We'll discuss that in a minute. The only other thing that we have connected is, notice up here on inputs 0 and inputs 1, we have a yellow and a purple wire. So the only thing we have connected to the CR30 is power, and we're bringing in 2 fill devices from somewhere else. Now, let's consider the somewhere else. Okay, now we have a decent shot of the entire circuit, and you remember we have 2 connections up here coming back from our EStop buttons, and we're supplying 24 volts DC from here. In other words, we're coming from over here where our minus and plus is to our minus and plus here. And then we're taking the channel 1 and channel 2. Let's just call yellow channel 1 and purple channel 2, because up here we're hooked to input 0 and 1. And we're taking those conductors and we're feeding them both channel 1 and channel 2 24 volts DC, just like the diagram. And you notice that these are jumper together and these are jumper together. So in the future, anything that's channel 1 going back to input 0 is going to be yellow and go through this set of blocks. and then vice versa for input 1 going through this set of blocks. Come in with channel 1 and channel 2, 24 volts DC, into these two sets of contacts that go to the EStop. So when we operate the EStop, it's going to, when you push it, it's going to remove 24 volts from these two wires coming up here to the inputs. Right now it's normally closed, so if the stop button is out, then both contacts are closed, and we have 24 volts going to both input 0 and 1. Now I'm trying to keep as many wires and devices off of this as I can and just have exactly what we need for each lab project. So right now we've got 24 volts DC coming in to the safety controller. We've got a dual channel EStop coming to input 0 and 1, and we're feeding it straight up 24 volts DC. So there's no pulse testing. So this is the first one that we're going to work with. So now let's go and do the program for this real simple circuit. Let's create a project for our CR30 with a 2-channel EStop button, no test pulses. So we have connected components workbench open. So we'll say new, and I'm going to select CR30 underscore 2-channel underscore EStop push button. Create. Now these are the 5 categories that we can pick from if we're creating a project for connected components workbench. We're going after safety, but just in case you've never been here before, there's the micro 800s, there's the drive, including the 525 that falls under this class, amongst other ones. And if you're doing motion, you can use a Kinetics 3. And motor starters, graphic terminals, panel view 800, and there is a faceplate for the CR30 for panel view 800. I don't know about panel view component, but we're going after safety, 440C. You can see there's light curtains there too. So we select 10 is the highest firmware level for the CR30, but we are using version 13 of CCW. But that has nothing to do with the 440C CR30 unless there was a higher firmware level in the 440C than what we had for CCW. That might be an issue. So let's keep it simple. Add it to our project, and then in our view, we want controller organizer and we want project organizer. That doesn't always pop up by itself. In times past it did. Lately I have to open it. So let's double click on the Guardmaster 440C CR30, and there's our puppy that we're playing with. And we could go in here and set up some things. I'm trying to remember what the Ethernet address is that I have. So I'm going to go to RSLINKs. I'll minimize this, go to RSLINK Classic, and go to Ethernet IP, and I see that I had it set up for 130. Okay, that's what's in it now. You see the little red X, that's because it's not powered up and connected. Let me do that and I'll be right back. Well, looky there. I plugged it in, powered it up, and now it's there. Along with some other things that are powered up that we aren't concerned with. The only thing we care about is this Guardmaster CR30. So we'll close or minimize RSLINK Classic, go back to CCW. We'll go to our plug-in modules because our CR30 has a Ethernet plug-in module and an I/O expansion module plugged into these two plug-in ports right here. So we'll go and we'll add a communications, and there's only one for communication, that's the ENet. Okay, notice that disabled the serial port up here. See this round 8-pin DIN connector? It's disabled now. Not the USB, but the RS-232. So we'll configure the IP address, and I'm making it 100, 100, 100, 130, because that's what it's already set at. And the subnet mask, 255, 255, 255. Whoops, got a little fat finger in there. That's a 5, and that's a 0. Not to digress into Ethernet, But whenever you see a 255, and by the way, these are octets, meaning 8 bits. Y'all know that 8 bits is 0 through 255. You have 256 values, 0 through 255, because 0 counts. The subnet mask is actually the address of the network itself, not nodes on the network, but the network. So when you see 255, 255, 255, then these first 3 octets up here, that is the address of the network. 130 is a node on that network. The network is 100, 100, 100, and the node is 130. Now, if I drop this by a value of 1, I just doubled the number of nodes that can be on that network. But let's not get too carried away with all that right now. Now I'm going to add another module, and it's the IQ4 OB4, because that's exactly what I've got in my CR30, and I don't want to be getting errors that, you know, I show one configuration, then when I go to download it says, well, that's not what we have down here. Okay, so that sets us up, and at this point we probably could download, but there's nothing to download. So let's go into Edit Logic, and you see we have nothing. So let's go to the toolbox over here. We'll drag in an emergency stop button over here to our safety monitoring. And notice that it by default is embedded input EI00. And my choices are the first 18 points. Remember, in an earlier lecture, I showed you 0 through 11. That's 12 of them. Those are safety inputs, embedded safety inputs. 12 through 17 are specialty or multi-purpose terminals. Notice that 12 and 13 are grayed out. I can't select those because by default it picked the first 2 unused safety inputs for my 2-wire coming in, and then it selected the first 2 of the multi-purpose for our test source A and B, but we're not going to use a test source A and B, so we're going to delete that. So we have no test source. We'll look at advanced settings just so your pulse testing disabled, discrepancy time. Now just for grins, I'm going to run this down to 0. I think if I make it 0, it won't do the test. I'm going to make it 1, okay? And no input filter. Now, from here, we need to turn something on. And I believe we had 17 and 19. So we'll go to immediate off. And we'll drag that up here to safety output. I'm going to drag the output of this. Whoops. Click there. Click over there. And what it did was it created 2 pass-throughs. Now, we did a little of this before in previous lecture. You got safety monitoring, logic level A, logic level B, and safety output. So you are somewhat limited in how complex or convoluted you can get with your logic between safety monitoring and safety output. You got 2 levels, A and B. And anything that you can put in A, you could put in B. So if you had one logic thing that you wanted in here, you could put it in A or B. There doesn't have to be something in A in order to have a B. You can pass through level A or level B, or in this case, both, because remember, we have a 2-wire or 2-channel EStop application. And the reset type, I'm going to make it auto. I'm going to make it auto, and you'll see why. Okay, that's a configuration right there. We got an EStop button, 2 channels, and we're turning off 18 and 19. Let me look to see which 2 I had wired up. So I connected my immediate off up, and I configured it for embedded output 18 and 19, and now we're going to check this out. Okay, this logic by itself would turn on and off embedded output 18 and 19. And if you remember when we looked at the actual hardware, I did not have anything hooked up to 18 and 19, not yet. It was at one time, and I disconnected it to try to make everything look nice and clean and empty. So I went back and connected those, a couple safety relays, force-guided contact relays, back in there so they're controlled by embedded outputs 18 and 19. But we could probably still turn on and off those outputs with nothing hooked to them, but it sure wouldn't serve any purpose, because when we hit the EStop, if something wasn't turned on, then nothing can be turned off. So let's see if we can download this and check it out. So I'm going to go to, well, first I'll save it. I'll go up here and I'll hit the save. I'll go to the Guardmaster and connect to device. And it brings up an RS-WHO looking thing. You should recognize it. And it sees that 100, 100, 100, 130 is there. So I say OK. The current project does not match the content in the connected safety relay. And that's because the program that's in it now is one that I was using to test out something for a project. So I'm going to say I could upload the project, and that would overwrite the logic that we just created. But I'm going to say download the current project. Download success. Do you want to change the safety relay back to the run mode? Yes. Okay, now we can go to edit logic, because we are connected, and we can see everything's green. Now I'm going to push the EStop. Notice that everything went off. I'm going to pull the EStop back out. It may all go green, or we may get a discrepancy fault. Remember that I dropped the discrepancy time down to 50 milliseconds. It's a multiple of 1 of 50 milliseconds. Oh, it came back green. So there's a couple times that when I did that, I actually got a discrepancy fault, and I'm going to try it a couple more times. Okay, this time I got a discrepancy fault when I pushed it down. In other words, when I tripped the EStop, and the way that I caused it to do that is I pushed it really slow. Because remember that this is one of those maintained EStop buttons. We'll talk about that here shortly. And it mechanically detents or latches in the depressed position, which means that it's pushing on both contacts simultaneously when you're pushing down. So I got a discrepancy fault. I'm going to clear the EStop, and now it's happy again. Let me do that again. This time I pushed real fast, so I didn't get a discrepancy fault. Now I'm going to release it slowly to see if I can get a discrepancy fault on the release. And I did. Oh, I got a channel fault too. Excellent. Channel fault and a discrepancy fault. And that was all because, you remember the input filter is set at 0. So there's no room in there for bounce. So let's play with those a little bit. I'm going to reset it. Now remember, the reset is auto. See over here, auto, which means when I release the EStop button, I have to push it down and release it again. And then you remember that from the timing charts. So both of them had to go off and then back on. For this simple little project, I think we're going to call this one, it's everything we're going to get out of it. So now let's actually go look at the hardware. First thing I want you to notice is I turned some of the light down so you could see that the run light over here is flashing. See how the run light is flashing? There's a reason for that. Let's jump back over to our device. It's in the run mode. We need to verify our program. Now the verify, it's not really a software function because what we're going to do is just check off these boxes. Have you blah, blah, blah. You can read these on your own sometime. It's just a list of things. Have probability values been calculated according to the system's configuration? Have you performed all the appropriate functional verifications test on the system? It's never going to be verified unless you check off these boxes. And when you check off these boxes, you are saying that you did all these things. That way, if something occurs and someone gets hurt, they'll go back and say, well, somebody verified this. So let's go ahead and generate that. You may not have heard it, but I heard the system behind me click. So I know that the online system recognized that it was verified. See, safety verify success. Now notice that that green light is not flashing anymore. I'll zoom in a little bit so you can see that second LED right here is no longer flashing. That's because we just verified the system. And that's one of the safety checks. You might get this thing to work, but it won't be. Here's our two safety relays that we added back in. See, from 18 and 19. And I'm maintaining the yellow and the purple. When I watch right here, that little gap right there, you see it went red right there. Now watch where my finger's at when I pull the EStop back out. See, I had my finger in front of it. Right there. See the little black space? Now we don't actually have these safety relays connected to anything. So we're not controlling motors or anything. I just threw in these two relays here. These are force-guided safety relays to run off of 18 and 19. This would be K1 and K2 basically in your safety circuit. New camera. I apologize for the awkwardness. The camera that I had been using since 2005. That's 17 years. It was a very nice high-end Canon digital. And all of a sudden, the images went streaky. It had streaks through them. It was an electronics problem. It wasn't optical. So there was no saving the camera. They don't even service them anymore. So I got this new camera, and I hope to do better on the next session than I did on this one. So we'll finish up this one, and then we'll do the next one a lot smoother.